So, dear all, today at another video of deep learning about object detection. So, last class we have already learned about the difference between, you all know that what is prediction, what is regression, what is classification. So, here in this video, we are going to learn about what are the difference between object detection and classification. Basically, if we are talking about computer vision, one of the main real life problem is like surveillance detection, vehicle detection, traffic detection. So in all these applications, this object detection plays a vital role. So this video is mainly basics on what is the difference between detection and classification, what are the different architectures used for object detection, what are their disadvantages, advantages, etc. So first we want to know what is object detection. So as we are saying object detection in an image, what is classification? Classification is basically on the basis of whether it is a dog or not, whether it's a cat or not. But object detection means in a video. So if you are talking in an image, there will be many objects are there, not a single object are there. So in object detection means we are going to detect each and every images or each and every things, objects inside an image. So the main difference between detection algorithms and classification algorithms are, in detection algorithms there will be a bounding box around the object of region of interest within the image. So if there is one object is there, then we have one bounding box. If two objects are there, we have two bounding boxes. Like that, how many objects are there? Similarly, we have that much bounding boxes are there. So this is basically a classification problem and a object detection problem. See here, maybe in one image, in this image, first image, there is a cat face. Only one cat face is there, right? But in below face, there will be duck and many ducks are there. So we require that much object of interest within the image, and you would not know how many beforehand. Okay. So why can't we detect the object? Why can't we require an object detection algorithm separately from a classifier? Due to all these reasons. What are they? The length of the output layer is variable, not constant. Why? It is because why? Because the number of occurrences of the objects of interest is not fixed. In the image, there will be maybe several objects of interest. So one problem to solve this is that to take different region of interest from the image. Okay, to take different region of interest from an image, and we can use a CNN to classify the presence of that object within that region. But again the problem will be there, because the objects of interest might have different spatial locations within the image, and there may be the region of the object that we wanted may be cut off because of that region of interest, and different aspect ratios will be there. So this is not practical in real life. So what would be the reason? So we have to select a huge number of regions in an image, and then what we need to do? So if a huge numbers are there, maybe one object may be cut off. So similar regions are there in that bounding boxes. Similar regions are there. That similar regions we need to warp it, or we need to combine it and make it a single region of interest. So similarly, a huge number of regions, and this could be computationally blow up. So therefore, we require for object detection algorithms, separate algorithms are required. They are RCNN, YOLO, faster RCNN, etc. So in this video, we are only going to see what is RCNN, disadvantages of RCNN, and then directly jumping on to faster RCNN. YOLO we will be directly explaining in the next one-to-one class. Okay. So what is RCNN? To bypass the problem of selecting a huge number of regions in the region of interest, we are proposing a search method. The search method is called a selective search method, selective grid search algorithm, and will extract about 2000 regions from the image, and these regions are called as region proposals. Okay, so these 2000 regions, it will selectively search for the object inside that image. So what is the selective search algorithm? Initially there will be a sub-segmentation of the image. Then using greedy algorithm, recursively we will combine the similar regions into larger ones. Similarly, we will use the generated regions to produce the final candidate region proposals. Region proposals matlab, these region proposals contains the objects that we wanted to detect. Okay. So this is the structure or architecture of RCNN. Here regions with CNN features. First will be the input image. Then we are going to extract about 2000 region proposals. Then we are going to warping the region. Warping the region matlab, we are making it into a square shaped. Then we are feeding this warped region into CNN layers. CNN will act as a feature extraction, and this feature extraction layer will given to the fully connected layer. It will classify according to whether aeroplane, no or yes. There is detection, there is no classification. Here detection, aeroplane is there, no. Person is there, yes. TV monitor is there, no. Likewise it will be classified. So it will happen in the 4 regions. So what is the disadvantage of this? So the same thing we have explained it. 2000 candidate region proposals are there. It will be again warped into a square shape and then fed into a convolutional neural network. This CNN will produce a feature map or a feature vector of 4096 by 49096. Then this CNN acts as a feature extraction and it given to the output layer. It will be an SVM or any classification layer. It will be classify the presence of the object within the region proposal. Candidate region proposal is the final region proposal after the grid search algorithm. Then in addition to that, predicting the presence of an object within the region, but the algorithm also predicts 4 values, which are the bounding box, offset values, to increase the precision of the bounding box. That is the exact location of the object. Whether object is there or not, it will be there in the object detection. Then the object, where is that object? It is also located in that. That is the difference between object detection and classification. Okay. Now, for example, this is another view of that. That is, the image will be there, several region proposals, convolutional neural network, feature map. So the output will be the classification as well as detection, the location of the object as well as whether the object is there or not. Okay. Now, what are the problems of RCNN? RCNN, it will take huge amount of time to train the network. That means because this 2000 region proposals implementation is too difficult, and for one test image it takes about 47 seconds. Selective search algorithm is a fixed algorithm, therefore no learning is happening at that stage. So what happened? This could lead to the generation of bad candidate region proposals. Bad candidate matlab, maybe the object will not be there inside that region proposal. Here comes the faster RCNN. So this faster RCNN, what is the benefit of faster RCNN? Faster RCNN is mitigating the problem of this large 2000K region proposals by avoiding this selective search algorithm. Instead of that, it will be having its own network called region proposal network. So faster RCNN will mitigate the problem of time consuming of selective search algorithm by implementing a network called region proposal network, which it will learn itself the candidate region proposals by themselves. So there is no any 2000 region proposals generation or selective search. Selective search is a gradual process. There is no that process, or there is no learning happening in the RCNN, but faster RCNN, it is learning by itself. So this is faster RCNN. Faster RCNN I will explain in the next video. Thank you.